Hello class 11th, welcome to KEAM Crash Course Complex Numbers. So you guys were demanding a lot for complex numbers. So here it is. I will be revising entire chapter for you, giving you all the formulas and showing you all the PYQs. That is, in the past 5 years or 10 years, what type of questions have come from this chapter. We'll practice that also. Okay. So as you guys know, complex number is important because every year 7 to 8 questions definitely come from this chapter, right? So yeah, let's start this. But if you are new on the channel, don't forget to subscribe also, okay? Because if you don't subscribe, you won't get the notifications, you won't be able to see the formula cheat sheet which is coming very soon, and marathon series for your KEAM 2023 preparation. Okay guys, now let's start with complex numbers. This is the syllabus of complex numbers for you this year. So let's learn all the topic one by one. Okay. Now first, it is very important that you should know the formula for calculating root of any quadratic equation, because from this root only complex number was invented because of negative roots like root of -1, root of -2. So this is, if you want to get root of a quadratic equation, this is the formula which you should know. So if your discriminant is greater than 0, real and distinct roots. If it is equal to 0, real and equal roots. If it is less than 0, then complex number, yani virtual roots are there. Okay. Now, how do complex number look like? So if you see any number which is written like that, x plus iy. For example, if you have any complex number 2 plus 3i. Now what is this I? I is iota symbol. Or if you see a number e to the power 3 plus 4i. This is also a complex number. So wherever you see this I or you see z, because z is also used to represent complex numbers only. Okay. So wherever you see this, you should know that it is a complex number question. Okay. Now, in complex number, every complex number has a real part and imaginary part. So suppose your complex number is 4 plus I. So the part which is not having I is called as real part. And the part which is there with I is called as virtual part. Imaginary part. What do we call it? Imaginary part. We also call it complex part. Okay. So remember. Now, in the question, if they say that the given two complex numbers are equal. So when are they equal? If the real part is equal to the real part and if the complex part is equal to complex part, only then you can say that Z1 is equal to Z2. So if A is equal to C and B is equal to D, only then you can say that Z1 complex number is equal to Z2 complex number. Clear? Okay. Now, suppose this type of question comes that 3x plus I of this is 3 minus 6i. Then what is the value of x and y? Now they are what? Equal complex numbers. So their real part will be equal. So 3x will be equal to 3. So x will be equal to 1. Similarly, 3x minus y is equal to minus 6, because I part will be equal to I part, imaginary part. Now x is 1. So 3 into 1 minus y is minus 6. So 3 plus 6 is equal to y. So y is basically 9. So here you have x is 1, y is 9. So it should be 1. It will not be 3. Okay. Now, algebra of complex number, how you add, subtract, multiply or divide, it is very important. It is used directly or indirectly at a lot of concepts. Okay. So how you add complex numbers? So if you have two complex number, a plus ib, c plus id, what you do is z1 plus z2 will be real part with real part plus I times of imaginary part plus imaginary part. Similarly for subtraction also. Okay. Now addition has some properties. Closure law. If you add two complex number, you will get a complex number only. If you change the order of addition, the answer will be same for two complex number. If you change the brackets for two complex number, the answer will be still same. Associative law. Additive identity, for a complex number, if you add 0 plus 0i, then you will get same complex number. Additive inverse, for a complex number, minus of z1 will be additive inverse of that number. Okay, because if you add them, you get 0. Now, how you subtract complex numbers? So, z1 minus z2 will be basically what? Real part minus real part. So, 6 minus 2 plus I times of imaginary minus imaginary. So, 3 minus minus 1. So, it will be 6 minus 2 is 4. I times of 3 minus minus 1 is 3 plus 1, 4. So, this will be your number. This is how we do subtraction, okay? Now, how you do multiplication? Just open the bracket, use distributive law. So, suppose your complex number is a plus ib into c plus id. So, what you do? First, you multiply a with c plus id. Then you multiply ib with c plus id. So, you will get ac plus adi plus bci plus bd into I square. Now, what is I square? I will tell you after some time. Okay. Now, what are the properties of multiplication of complex number? Closure law again. If you multiply two complex numbers, you will get a complex number only. If you multiply two complex number in different orders, answer will be same. Again, if you multiply three complex numbers z1, z2, z3, then brackets do not matter. Associative law. Multiplicative identity is, if you have a complex number and you multiply it with 1 plus 0i, then you will get same complex number. Multiplicative inverse is, if you have a complex number a plus ib, then its multiplicative inverse is a complex number which when multiplied gives you 1 as the answer. Now, what should be this complex number? We will learn after some time, don't worry. Distributive law is, if you multiply a complex number with addition of two complex numbers, you get z1 into z2 plus z1 into z3. That is distributive law. Okay. Now, how do you divide two complex number? So, we do not divide complex numbers. What we do is, z1 divided by z2 becomes z1 multiplied by 1 upon z2. Now, 1 upon z2 is called as multiplicative inverse of z2. Now, what is this? We will learn, don't worry. First, we need to learn conjugate, then only we will learn this. Now, power of I is very important. So, I to the power 1 is I to the power 2 is what? Now, you know, I is basically root over minus 1. So, I square will be root over minus 1 into root over minus 1, which is basically what? Minus 1. So, I square is minus 1. Remember, I cube is I square into I. So, it is minus 1 into I. It is basically minus I. And I to the power 4 is I square into I square. Minus 1 into minus 1. It is plus 1. So, now these rules are important. Why? Because if you have any number, you can convert it to a multiple of 4 and then remaining will give you the answer. Okay, for example, if you have I to the power 50, I to the power 50 can be written as I to the power, take a multiple of 4, 48 plus 2, 48 plus 2 is 50. Now, what is 48? 4 into 12. So, this is a multiple of 4, it will become 1. So, this is I to the power 4 into 12 into I to the power 2. Now, this is 1 because any number, any multiple of 4 is 1. I square is minus 1, so answer is minus 1. Like this you will get your answer. Okay, so only the remaining portion will give you the value. If you have 50, just divide it by 4. Whatever is your remainder, that is your answer. Okay, so if your remainder is I square, your answer is minus 1. If it is I cube, your answer is minus I. If it is I to the power 4, your answer is plus 1. Remember? Okay. Next is modulus of a complex number. Important concept. Mod value means the magnitude of it. How we calculate that? If you have a complex number z written as a plus ib, the mod value will be root over a square plus b square. Root over a square plus b square for a complex number. Okay. Now, very important, conjugate of a complex number. What is conjugate? If you have a complex number a plus ib, conjugate of this complex number is write a as a, write this as minus ib. So, what you do? Change sign of imaginary part. Whatever is your imaginary part, just change the sign. If it is positive, make it negative. If it is negative, make it positive. Okay. Now, this is again, if it is x plus iy, it becomes x minus iy. Now, we are just replacing I with minus I to find conjugate. Now, some important properties. Mod of z1 into z2 is mod of z1 into mod of z2. Mod of z1 divided by z2 is mod of z1 divided by mod of z2. Conjugate of z1 into z2 is conjugate of z1 into conjugate of z2. Conjugate of z1 plus z2 is conjugate of z1 plus conjugate of z2. Similarly, conjugate of z1 by z2 is conjugate of z1 upon conjugate of z2. These are the properties of complex numbers and conjugates. Now, using the property of conjugate, we now find out multiplicative inverse. So, if you have a complex number a plus ib, what is the multiplicative inverse of this complex number? It is basically 1 upon a plus ib. Now, this is equal to, in the numerator you write conjugate, in the denominator you write modulus square. So, this is basically multiplicative inverse of a complex number is conjugate of complex number divided by modulus of complex number square. This is the formula for multiplicative inverse. So, if you have a complex number a plus ib, the multiplicative inverse will be a minus ib upon a square plus b square. Okay, this is used in many questions. It is very important. Next is Argand plane. Now, what is an Argand plane? A plane that consists of complex number. So, if your x-axis is real numbers and if your y-axis is imaginary numbers, then that plane becomes Argand plane. Okay. Now, in the Argand plane, we have polar representation of complex number. What is polar representation? Take any complex number as a point. The distance from the origin will be modulus of z called as r, and let it make an angle of theta with the x-axis. Then polar representation of this complex number will be r cos theta plus I sin theta. So this is basically x plus iy. It can be written as r cos theta plus I sin theta. Now, complex number can also be written in this form. Suppose you have a complex number z, x plus iy, and we have e to the power z, that is e to the power complex number, e to the power x plus iy, then it is written like this. Please remember, it is used in many questions. So, e to the power x plus iy, if you have any complex number like this, you can write it as e to the power x into cos y plus I sin y. Cos y plus I sin y. Remember? So here the real part will be e to the power x cos y and the imaginary part will be e to the power x sin y. Okay? So in complex number we can represent it in the power of e like this. Next, very important, principal argument of a complex number. Every year they ask question from this. What is principal argument? If you have a complex number x plus iy, the argument of z is tan inverse of y by x. Please remember, super important formula. It is tan inverse of y, that is imaginary part, divided by real part. Got it? Now only these formulas are used every year. Apart from this, you don't need any other formula from complex chapter. Okay? Now let's practice the KEAM PYQs. Only they will give you an idea what type of question will come. Right? Okay, let's start. Find the real part of this number. Just now we have seen, if a number is of the form x plus iy, you can write it as e to the power x into cos y plus I sin y. So here my number is e to the power 3 plus 4i whole into x. So this is x, this is also x. So I can write this as e to the power 3x into cos 4x plus I sin 4x. Now they are asking only real part. So real part is only this multiplied with this. So e to the power 3x into cos 4x. This is your answer. Let's check. Yes, this is your answer. Okay. Next. If 2 plus I is a root of this quadratic equation, then C is a real number equal to what? How we find root? At the beginning of the session I told you, for root the formula is minus b plus minus square root of b square minus 4ac upon 2a. है ना? Right? Now in the question they have given, this root is nothing but 2 plus I. So this root is 2 plus I, right? But wait, now here, first of all, you need to find the root. Let's put the values. This is A, this is B, this is C. So, minus B, minus of minus 4. Minus of minus 4 will be plus 4. Plus minus root over minus 4 whole square minus 4 into 1 into C upon 2 into 1. So this is 4 plus minus root over 16 minus 4c divided by 2 divided by 2. I am just separating it. Why am I separating it? I will show you. Wait. Now you divide, what will you get? 4 by 2 is 2. 2 plus minus. Now let's bring this 2 inside the square root. So if you bring 2 inside the square root, it becomes 2 square, that is 4. So this will be square root of 16 upon 4 minus 4c upon 4. 4 cancel, 4 is 16. So 2 plus minus square root of 4 minus c. Now in the question they are saying that one of the root is 2 plus I. So 2 plus square root of 4 minus c is equal to 2 plus I, right? Now here C is a real number, but we are getting I. How we will get I? Only, see, 2, 2, matching, plus, plus, matching. This implies what? This means that root over 4 minus C is equivalent to I. Now what is I? I is square root of minus 1. I is square root of minus 1. You remove square root, you get 4 minus C is equal to minus 1. So C is equal to 4 plus 1 is equal to 5. This is your answer. So C value is 5. Okay. So basically we got 2 plus square root of 4 minus C is equal to 2 plus I. So this implies that square root of 4 minus C is I. Now what is I? I is root over minus 1. So from here we get 4 minus C is minus 1. So C is 1 plus 4, that is 5. Understood? Next, super easy question. Mod of Z1, mod of Z2 given, mod of Z1 plus Z2 given. Asked is this. Very simple. Mod of 1 upon Z1 plus 1 upon Z2 will be, just take LCM and cross multiply. Mod of Z2 plus Z1 upon mod of Z2 plus Z1 upon mod of Z1 into mod of Z2, right? Now what is Z2 plus Z1? Z1 plus Z2, Z2 plus Z1 same. So it is 3. Z1 is 2, Z2 is also 2. So it is 3 by 4. So easy. 3 by 4 is your answer. Okay. Next, what is the principal argument of this complex number? See, every year they will ask you principal argument. First, what is the value of sin pi? 0. You should know trigonometry value. What is the value of cos pi? Minus 1. So, therefore, z is 1 plus 0 minus I into minus 1. 1 plus 0 plus I into minus 1. So, you get 1 plus I upon 1 minus I. Now, what you do? Always, if you have in the denominator I, you rationalize it. How you rationalize it? In class 10th we have learned, just multiply it with opposite sign. So, 1 minus I multiplied with 1 plus I. This also multiplied with 1 plus I. Simple. Just multiply, you get 1 plus I whole square. This is a square minus b square. So 1 square, or simply complex number multiplied with the conjugate is modulus whole square. So modulus whole square will be 1 square plus 1 square, right? So here you have now a plus b whole square, a square plus b square plus 2ab upon 2. Now this is 1 minus 1 plus 2I upon 2. 1 minus 1 cancel, 2 cancel, you get I. So I means what? I means what? Now your complex number, suppose your complex number is x plus iy and x plus iy is equal to I. So this implies that x is 0 and y is 1. Now you want argument of the complex number. Argument of complex number is tan inverse of y by x. So tan inverse of 1 by 0, right? Now what is 1 by 0? Infinity. So tan inverse of infinity is 90 degree, because tan 90 degree is undefined. Now 90 degrees pi by 2. This is your answer. Understood? First you have to simplify the complex number so that you know what is x, what is y. Then only you can find out argument of that complex number. Okay? Next. Z1 is a complex number, Z2 is a complex number. Find mod of Z1, Z2. Very easy question. Just add the complex number. Z1 plus Z2 is 2 plus 3. 3 plus 2, I. So 5 plus 5I. So mod of Z1 plus Z2 will be mod of this. So it will be square root of 5 square plus 5 square. So it is square root of 25 plus 25. So this is basically square root of 25 is 5. So it will be 5 root 2. 5 root 2. Okay. Next. This is equal to what? Rationalize it. 10I upon 1 plus 2I. Multiply. Opposite sign. Multiply with conjugate. 1 plus 2I multiplied with 1 minus 2I. 1 minus 2I. So what will you get? 10I. 10 2s are 20. And I into I is minus 1. So plus 20. Upon 1 plus 2i into 1 minus 2i will be 1 square plus 2 square. So this will be 10i plus 20 upon 5. So 5 2s are 10, 5 4s are 20. This is your answer. 2i plus 4. 2i plus 4. Okay, simple. Now this is very interesting question. Here it should be minus sign. Mod of z is greater than equal to 2. Mod of z minus 1 by 2 is greater than equal to k. Then minimum possible value of k is what? See. Mod of z minus 1 by 2 is greater than equal to k. That means mod of z minus mod of 1 by 2 is greater than equal to k. Now mod of z is what? Minimum value. So minimum value for mod of z is 2 because it is greater than 2. So 2 minus 1 by 2 is the minimum value for k. What is 2 minus 1 by 2? 2 2s are 4, 4 minus 1 3. 3 by 2 is the minimum value of k. They are asking minimum value of k. So your answer should be 3 by 2. Okay. Next, again, interesting question. If the determinant is equal to x plus iy, then what is x? What is y? First, find out determinant. So, how you find determinant? First number, remove row, remove column. 9i into I minus 9. Minus of minus plus 9. Again. Next will be minus of minus 9i into 2i minus 10 plus 1 into, lastly you have this number 1 into 9 2s are 18, 10 9s are 90i. Solve it. Now minus 9 plus 9 is 0. So 3i into 0. Minus of minus plus 9. So this will become plus. 9 2s are 18. I into I is minus 1. So minus 18. Then minus 90i plus 18 minus wait, we are doing mistake in the sign somewhere. This will be 2i. Oh, this is plus 10, sorry. So we have plus 90i. Here it is minus 90i. Now this is 0. Minus 18 plus 18, 0. 90i minus 90i, 0. So this is 0 plus 0i is x plus iy. So what is x and y? 0. So x is 0, y is 0. Okay. Next, if z is cos pi by 3 minus I sin pi by 3, then z square minus z plus 1 is what? Now what is cos pi by 3? What is cos pi by 3? Cos 60 degree 1 by 2. Sin 60 degree root 3 by 2. So this is z. In the question they are asking z square minus z plus 1. So 1 by 2 minus root 3 by 2 I whole square minus 1 by 2 minus root 3 by 2 I plus 1. Z square minus z plus 1. So what is z square? 1 by 2 whole square. Then you have root 3 by 2 I whole square. Then you have 2 times of 1 by 2 root 3 by 2 I. Then you have minus 1 by 2 plus root 3 by 2 I plus 1. So finally you have here, okay, so we get 1 by 4 minus 3 by 4, 2 cancel, minus root 3 by 2 I, then minus 1 by 2 plus root 3 by 2 I plus 1. So minus root 3 by 2 plus root 3 by 2 cancel. 1 by 4 minus 3 by 4 is minus 2 by 4, that is minus 1 by 2. So minus 1 by 2 minus 1 by 2 plus 1. So this is basically minus half, and minus half is minus 1 plus 1. It is 0. So my answer is coming 0. Okay. So this is the value. So simply whenever trigonometric function is given, just put the value. You get the answer. Next, I to the power 9, I to the power 19. How we simplify it? So, I to the power 9, I to the power 19. Convert it into multiple of 4. So, this is I to the power 8 plus 1, I to the power 16 plus 3. 4 2s are 8, 4 4s are 16. So, this will become I to the power 1, I to the power 3. What is I to the power 1? I. What is I to the power 3? Minus I. What is I minus I? 0. So again your answer is 0. So 0 can be written as 0 plus 0i. So that's your answer. Done. Nothing else. Alright. So guys, I have shown you all the different varieties of questions. Each and every question was different, asked every year. So you see trigonometry is also used, argument is also asked, then conjugate is also asked, power of I is also asked. So everything is asked in the question paper, everything is important. So just memorize all the formulas I told, okay? And here is the complete mind map for you. All the formulas are written here. What is I square, what is Z? If you add them, subtract them, multiply them, divide them, then a complex number into conjugate is modulus Z whole square. What is mod Z? What is conjugate of Z? De Moivre's theorem, all the theorems related to conjugate of complex numbers. Here also all the formulas related to conjugate of complex numbers. Everything has been written. Complete formula cheat sheet is here for complex number, okay? And this is also the summary of entire chapter. What is iota? What is a complex number? What is the real part? What is the imaginary part? Examples of complex number. How you add them, subtract them, multiply them, divide them. Everything is summarized here. How you find modulus, how you find conjugate, properties of modulus, properties of conjugate, everything, literally everything is there in this formula cheat sheet. You don't need to go anywhere else. Just revise all of this and you are done. Entire chapter is done. Okay, so hope this session was useful for all of you, and if you have watched this lecture, then complex number is done for you. You will be able to solve all the questions. So just memorize all the formulas, remember the PYQs. Just go through the question which I have solved. They are very important to give an idea. Okay, so thank you for watching. If you enjoyed, don't forget to like the video. Okay, subscribe because marathon series is coming, formula cheat sheet is coming, and many more lectures are coming for KEAM preparation before your exam itself. So do subscribe, don't go anywhere else. Thank you for watching. Have a good day. Bye bye.